probability probability the main questions are two questions. One is addition theorem and second one is Bayes theorem. But second one is deleted syllabus. So the important one is addition theorem. Addition theorem is important one. Before going to the theorem, we will learn some basics. And the first one is experiment, random experiment. Doing something is called experiment, but random experiment means if it satisfies the three rules, the experiment satisfies the three conditions, then we say it is a random experiment. What are that? What are those three conditions? Are it can be repeated many times, repeated many times, number of times, repeated any number of times, any number of times, the first condition. And the second condition is the outcomes. We know the outcomes, possible outcomes are known in advance. All possible outcomes of these experiment, all possible outcomes of all possible outcomes of the experiment are known in advance. Suppose, for example, is already you wrote the first year exams. The possible outcomes, the possible is what, the result is what, either pass or fail. Only two possibilities. If any student attempt the exam, is a experiment, writing the exam. The result is the outcome. Outcome may be two possibilities. That is either pass or fail. That is already we know the advance, we know the outcomes. But exactly we don't say that he is the pass or he is the fail. The third condition is for that actual outcomes in advance. We know the all the possible we know in a particular case it is and that means in a particular case it is not known in advance, all actual outcomes we know, but if you toss a coin we know either head or tail we will get, but particularly we doesn't know this time, third time I will get the head, fifth time I will get the tail, that we can't say. That is actual outcome in a particular case is not known in advance. Actual outcome, actual outcome of a particular case, actual outcome of a particular case not is not known in advance, is not known in advance. That is fourth time I will get the head, fifth time I will get the tail, like that we can't say. But we will get either head or tail, we know. But I will get head definitely. That is not correct. That type of experiment is called. That means all possibilities are same conditions. That means same. What is that? Suppose if that coin is very one side is thickly, that means weight is very high. Then when we toss a coin, every time we will get the same outcome. That means one outcome is it is this coin is favorable to one outcome. It is not fair. It is if the both the outcomes have the same chance is known as equally likely event. That means the outcomes are called simple events. Then all possible outcomes are called sample space. Here another word is sample space. Sample space means set of all possible outcomes. That means suppose is represented by S. In case of tossing a coin, we have head and tail. In case of rolling a dice or throw a dice, here roll a dice. You take the dice, six faces, one, two, three, four, five, six. Another one is that side. Six faces it have. The possibilities are when you throw a dice, we will get either one or two or three or four or five or six. This is known as the sample space. Any event means subset of sample space. Next, equally likely event. Equally likely event means in a sample space, every event have the same chance to occur. So that type of experiment is called equally likely events. That means equally likely means every event have equal chance to occur. Equal chance, equal chance to occur. Equal chance to occur. That is called equally likely events. Here S is equal to 1, 2, 3, 4, 5, 6. Suppose E is equal to 2, 4 and then E1 suppose. E2 is equal to 1, 2, 4, 5. Then if we observe these two, when when we roll your dice, then E2 maybe have the more chance to occur because it have four choices, but it has the only two choices. So in this case, even E2 are not equally likely events. Okay. Next is mutually exhaustive events. Mutually exhaustive events. If E1, E2 are two events, if E1, E2 are two events, suppose you take the above example only. E1 intersection E2 is equal to pi. If then only they are mutually exhaustive. Mutually exhaustive events. Above case E1, E2 are having the common element here 2 is there, so they are not mutually exhaustive. Next, after one mutually exhaustive and mutually exclusive. Here is mutually exhaustive means E1 union E2 is equal to, yes, mutually exclusive events means E1 intersection E2 is equal to pi. Then it is mutually, here you see once again I am explaining, mutually exhaustive events means E1 union E2 is equal to S. Here E1 union E2 is equal to S, then mutually exhaustive events. Suppose you take the above example is not a mutually exhaustive because even 6 is not present here. The next is mutually exclusive events. Next is mutually exclusive events. In this case, exclusive means E1 intersection E2 is equal to pi. Then we say they are mutually exclusive events. Then next, the important is the probability definition. You know from the 10th class onwards, probability definition. Here, in a probability of an event, E is represented by PE means probability of an event E. Here, this E is from the S only. So, the probability of E is equal to number of favorable outcomes for E, that is number of favorable NE by total number of outcomes from the sample space NS. NE by NS. The ratio gives the probability of, always the probability is the ratio. Here S is the total chances and E is the total number of outcomes. Here probability of E is equal to total number of results or outcomes, total number of outcomes, total number of outcomes, and favorable number of favorable outcomes for E, number of favorable outcomes for E. Always E is subset of S. Subset are equal to S. So NE is also subset or equal to NS. If it is equal to NS, we will have PE is equal to 1. This is always less than, that is the reason this value is always 0 is less than or equal to PE is less than or equal to 1 only, because this is a fraction, proper fraction. E is less than, NE is less than NS. Next one is probability function. Probability function. How we define probability function? It is represented by P like a function f. It is from PS to R. But what is PS? PS is all subsets of S. All subsets. R is a real number. Here S is equal to, suppose, head tail. When you toss a coin, we will get S is equal to head or tail. All subsets we have to write. Head, one subset, tail, and another one is head tail subset itself is a, and null set. They are mapped to real numbers. Suppose this is mapped to 1 and this is mapped to 1 and this is mapped to 2 and 5 is mapped to 0. Real number here. This is the PS, this is the function. This function, this is known as the probability function. From this one, we will take the four axioms. The first axiom means we will take directly, it doesn't have any proofs. The first axiom is probability of E is greater than or equal to 0. And the second axiom is for that probability function, probability of S is equal to 1. And the third axiom is probability of E1 union E2 is equal to probability of E1 plus probability of E2. This is from the probability function. And the fourth one is E1 less than or equal to E2. It gives probability of E1 less than or equal to probability of it. Suppose E1 is subset of E2, then also we will write like this. This is the very important. That is, probability function is the very important to write the addition theorem, to solve the addition theorem. This is very important to us.